Hello again. So I am Fresado. So I am from Bicol University, Pulangi. I am a student from Section 4B, and I am also a computer engineering student. So in this video, I am going to discuss my laboratory output for lab activity 15, which focuses on multimedia processing. So the objectives of this activity is to perform basic audio and image processing using Python and to also understand concepts like filtering, transformation, compression, and noise removal in audio and images. So I installed this library. So in this activity, I have used NumPy, SciPy, Matplotlib, Librosa, OpenCV, PyDub, and other libraries. So this procedure is divided into parts. So in part A, so we show the audio waveform and spectrogram from our results. So I use Librosa to load a simple trumpet audio file. So as you can see here in the plot, you see the waveform and the spectrogram. So in creating this spectrogram, so we computed the short time Fourier transform. And in this spectrogram, you can see the components of the trumpet, specifically the components of the trumpet, in which these notes are played. So I designed here a Butterworth low pass filter as indicated in the procedure to remove the high frequency noise. So we have here an denoise sound to preserve which preserves the tonal content of the trumpet, as you can see here. Next is part B, in which we perform image signal processing. So we have here an original image, and then by using Gaussian noise to the image, so it appears greenish. And to fix this, I also use a median filter. So this image, we treat this picture as a two-dimensional signal. So we loaded an grayscale image and also applied an Fourier transform to visualize its magnitude spectrum as seen in the plot. So as you can see here, the center represents the low frequency content since the original image has white in the center, and as it goes beyond, it has more content. So we apply a Gaussian blur and then a low pass filter, which results in the noise image. This is the blurred image, the noisy image, the original image. And this is the low pass filtered audio, as what I've said earlier, in which we apply the Butterworth filter to filter the components to remove the noise in the audio. So I have fixed. So let's go to the gate question. So we were asked here, so what do we observe in the spectrogram? So we see here the harmonic components of the trumpet audio, which are essentially the noise and the harmonic components, the notes of the trumpet audio. Another question is how does the low pass filter affect the quality and frequency content of the audio? So it reduces the high frequency components of the audio, which results in the smoother sound. As you can see here, since we filtered it using a Butterworth filter, so we preserve the tonal content, but we remove the noise. Another question is how would a high pass filter behave differently? So it would attenuate low frequency components and emphasize higher frequency details. So it makes the audio sound thinner and highlighting transients. So in the image, which is part B, so what information is represented in the magnitude spectrum of the image? So in the magnitude spectrum, so it shows the strength of the different frequency. As you can see here in the middle, so we have a white color, so it's black. So we have a lighter spectral frequency. So at this, as it goes to the outer region, which is black, so it represents high frequency domains, such as edges. So how does blurring affect the image? So it smooths the image in the spatial domain. So it reduces the sharp edges and the fine details. And while it attenuates the high frequency components, it just retains the low frequency content. So another question is how does the median filter help in noise reduction compared to the Gaussian filter? So the median filter reduces noise by checking each pixel with the median of this its neighbor pixel, and then it replaces it, which effectively removes the noise by smoothing the edges, and then it just preserves it. So that is all for this video. Thank you.